my name is Jean Curry. I am a robotics engineer, and I work for a company that's actually located right here in Vermont, in Richmond, called Green Sea IQ. And basically, oh, we gotta turn up the volume, sorry. Just say good. All right.
Yeah, and if you can just tip that a little closer to
Yeah. Okay. All right, sorry about that, you guys. All right, so as I was saying, I work for Green Sea IQ, and basically what I do there is I design and write software for a variety of different ocean robots. And I really kind of like this quote here that's off of our company website. I think it really encompasses the mission of what we do at Green Sea, and I'm going to tell you guys all about it. First, I'm going to tell you guys a little bit about how did I get here, what got me interested in this stuff. And basically, when I was in high school, a female friend of mine asked me if I would like to join the school's first robotics team with her. And I was a little bit nervous, but I thought it would be a good experience to learn how to, use tools and do some practical things that I, never really had a chance to learn how to do. But I ended up actually really falling in love with it. And so a little bit more about FIRST. It stands for Inspiration and Recognition of Science and Technology. It's an international robotics competition. There are different divisions for elementary grades all the way up through high school. And I did the high school version, which it's, as you can see in this picture here, they're big robots. The middle school version has smaller robots and even Lego robots. But basically, picture a sports game that's kind of being played by robots on this big field. And you have teams on either end, looking through these glass screens and remote controlling them around on the field. And basically the purpose of this program, is to inspire and motivate students to pursue STEM careers and, to become leaders and innovators in that field. And I would say it was very successful in helping me along to where I am today. And basically every year, this year I have a picture, the guy in the tie-dye shirt, that was one of my team mentors. He's standing next to one of our robots from that year. Each year a new game is released, and you only have like 6 weeks to design and build this robot. And we learn a lot throughout the process. It's pretty representative actually of kind of what it's like in the real world, when you get into industry and there are tough deadlines and things like that. It gave us some good practice on what that feeling is like. And I learned, beginning concepts in mechanical, electrical, software design things, and gave me exposure to the field of engineering, which, as a girl, we have less exposure to that idea of that being an option. So, I actually started as one of only just a few girls that were on the team. But by the time I graduated high school, over 50% of the team was female. And I think that, the more girls that you have, the more easy it is for other girls to look at that and say, hey, I kind of want to do that, or my friend's doing that. And it feels a little bit safer, it feels a little bit more like something they could picture themselves doing. And speaking of that, my mom and I later on started some first Lego robotics teams. That's the version for the middle schoolers. And we also had special programs for girls there as well. Like when a lot of times the girls feel a little bit shy, they don't want to contribute, but giving them some summer camps or like kind of girls only spaces to do that can really help them build their confidence so that they can join the mixed gender groups later on, and be really confident and have a lot of fun. So a little bit, about my college education after this. As a result of these great experiences I had with FIRST, I decided to pursue engineering. I also happen to have, a pretty deep love of science, earth sciences, and the ocean, and so I thought, hey, it would be pretty fun to combine these things. And so I decided to attend the Florida Tech, or Florida Institute of Technology, it's also known as, their ocean engineering program. As you can see, there's two wonderful institutions on this list. I did end up later transferring to SUNY Plattsburgh after taking a bit of an extended break from school. I unfortunately, even though I got pretty close to graduating at Florida Tech, ran into some financial problems, some personal things going on, and I needed to take a break, unfortunately, and I couldn't continue. So I actually spent a number of years working in between before going back to school at SUNY Plattsburgh. But both schools were really, really wonderful, and I definitely enjoyed them both for many reasons. And so between both of these schools, I studied a variety of topics relating to robotics and ocean engineering, things like software development, control systems, computer vision, AI, even naval architecture and offshore engineering and stuff like that. And in this picture here is actually a homemade underwater robot that I made for one of my classes at school. And the goal of this project was to make a little robot that would go in the swimming pool, and it would race other competitors across the pool. And this robot was one of the only ones that actually moved or did anything at all. So I was proud of that. Also, when I was at Florida Tech, I had this really wonderful opportunity to go out to sea on a research vessel called the RV Thunder Force. And what we were able to test out some of our class's senior capstone projects. So on the right that's a picture of us loading up a WingWave energy device. Basically, it sits on the bottom of the ocean, and it has like a wing on it that moves back and forth with the wave motion, and it stores energy. That can later be released as electricity. So it's an interesting concept in how to convert ocean wave energy into alternative sources of energy. And then in the other photo with me and my teammates, this was a really cool project that I did where this ROV is like an old ROV that was donated by a local research institution. And they basically handed it to us and said, hey, do what you want with it. And so what we did was we took out all the obsolete parts, we replaced them with modern stuff. I wrote a bunch of software for the top side and the robot side controllers. And this robot is now being used at Florida Tech in their underwater archaeology program to do exploration. And then at SUNY Plattsburgh, I did some cool stuff too. So we did some projects with this small little robot moving around that we called KIF. It stands for Keep It Fun. Because sometimes robotics can be frustrating, and you got to remember to keep it fun. The purpose here was, just to teach us some of the basic principles. We also used things like Arduino kits. These are like little microcontrollers that you can program and make circuits with and stuff like that. And this was a good way to get us, into the fundamentals. I also had the opportunity to do some pretty cool internships that, most of them were ocean related. So one of them here was at the Harbor Branch Oceanographic Institute. This project I did was for a coral health sensor. Basically, this handheld sensor, it records the water temperature and the color of a piece of coral when you hold it up to it. And it's all housed in like a waterproof diver's flashlight or light. And basically this is kind of meant to be used by Harbor Branch coral researchers to do surveys on the coral reefs in Florida, and actually, have some measurements of, what was the color of this coral, was it bleached or not, what was the temperature, the depth, et cetera. So this was a pretty fun little project. You can see me trying it out. Harbor Branch has a big aquaculture program, and they grow corals themselves in these big, long buildings. So I actually got to test it out on some real corals in their aquaculture center. The next one that I did was at the Monterey Bay Aquarium Research Institute. And you may have heard of its sister institution, the Monterey Bay Aquarium. The Research Institute does all sorts of oceanographic research, and it was really a privilege to work there for the summer. The project I was involved in was called FOS, or Free Ocean Carbon Enrichment Experiment, which is a mouthful. And this is basically an underwater science laboratory that's being used to conduct ocean acidification experiments in the Monterey Canyon, which is pretty cool. And I only had a tiny little piece of this. It was something called a load switching board. Basically, this protects all the scientific instruments on board from any dangerous electrical conditions like too much current, too much voltage, not enough voltage, and things like that. And just to give you a better picture of what this thing looked like, it's pretty giant. It's designed to study the effects of increased carbon dioxide concentrations in seawater on marine animals. And it's pretty important, because seawater is becoming more and more acidic as human-generated carbon dioxide levels go up in the atmosphere. And so researchers at MBARI, to them this is a really valuable tool to study the effects that this can have on sea creatures in the ocean. And basically it's this flume, and in the middle it very carefully controls the amount of CO2 that it's injecting into the seawater, and controls that pH very, very precisely. And on the left there, that's one of the little circuit boards that I programmed that then went into that thing. These next two don't really have a lot to do with ocean robotics, but these were some really fun experience anyway. This, I had an internship at a local manufacturing plant when I was living in Plattsburgh and finishing up my degrees. And basically I redesigned this box packing robot. All the parts, that drawing, I did that whole CAD drawing, and basically this video is, it come to life. So this was really, really fun and a good experience. And then one of the jobs that I had when I was in between school was this one at Bombardier, also in Plattsburgh. And basically I was an electrical test technician, and I got to do all kinds of different tests on subway trains. I mainly worked on the New York subway trains, the R179s, and did network testing, door system testing, communications, propulsion, braking, all the different subsystems on the train. And that also involved getting to drive the train around on the test track, which was super, super fun. So that brings us to Green Sea. So after I graduated, I was hired in 2022, right at the beginning of the summer. I was super excited. This is pretty much my dream job. As you can see from my history of internships and stuff like that, I really, really love this intersection of robotics and the ocean. So to find something like this here in Vermont is kind of surprising, right? But it so happens that this company exists, and it's a really, really wonderful company. So I am going to tell you some more about that. But before I get too far, I kind of want to just give you guys a bit of an overview about ocean robotics, and what ocean robots can do. So ocean robots, they're often used, when diving by humans is impractical or dangerous, such as working like in deep water or investigating anything that's hazardous under the water. They carry things like video cameras, sonars, lights, manipulator arms, and so they can grab things and essentially do things that would be dangerous or difficult for humans to do. And they can gather samples, do searches, do repairs, and record scientific data. And they can operate either autonomously, which means without a human directly controlling it, or they can operate with a human directly controlling it. So, and these are a couple of terms you will see a lot in ocean robotics, and that is ROV and AUV. And so I just want to tell you the difference. So AUV is an autonomous underwater vehicle. These are most commonly used for long duration underwater missions, such as detecting and mapping like submerged wrecks or just seafloor mapping and stuff like that. AUVs do not have a tether that connects them to the surface. So they can be gone out at sea for like months at a time with no human intervention at all. And they are pre-programmed to complete whatever tasks they are meant to complete. Whereas an ROV, it's still an unmanned robot, but an ROV is directly connected to the surface via tether, so it has power coming down and it has communications and control through that tether. ROVs, they can have, like I said, camera, lights, sonar, and they usually have some kind of an articulating arm. ROVs can be very big or very small. The large ROV to the left, that is the ROV Ventana, which belongs to MBARI, the Monterey Bay Aquarium Research Institute, where I had my internship. And Greensea also, my company, also happens to provide them with their custom software for this particular vehicle, which is pretty cool. And here it is, it's being launched from their research vessel. And then down at the bottom left, you can see a kind of a large control room that they have down in the heart of the ship. And they have a whole team of people, pilots. I've been in that room. It's basically covered in monitors. There's like a big chair that the guy controlling it sits in, and it's very cool, but very like intensive setup. And then on the right, we have a very small little ROV. That's actually one of the ones from my office. And there's a little picture of me down there, and you can see everything to control this ROV fits in one little Pelican case. So it's extremely compact and extremely easy to move around. So just to give you an idea of the variety of scale that these things can have. So why is ocean robotics so hard? Well, it's hard for a few reasons. One, of course, is the high pressures involved when you are at very large depths, and you have housings, motors, connectors. Water wants to get in those things, and so that's one of the things that makes it difficult. Corrosion and biofouling of materials. So biofouling is when you have things like mussels and algae and things that want to build up on the things that you have in the water. Those can make things difficult to deal with. You also have limited power on untethered robots like AUVs, right? So battery technology has to be able to keep up with the demands for long missions at sea. Also, navigation is very challenging in the water. And one of the things most people don't realize is that GPS doesn't work underwater. It uses radio waves, that come from space, and radio does not like to pass through water. So it makes it really hard. We have to rely on alternatives. And those alternatives are prone to drifting over time. And accumulate error. Communication is difficult. Like I said, radio does not go through water, so you can't drive an ROV around like you would like a remote control car. You have to send it either a signal through a tether, which can, by the way, get tangled and stuff, right? And it's heavy and it's unwieldy. Or we do have instances where you can send some data via an acoustic modem, which is using sound waves to send data through the water. But those have very low bandwidth. You can't push a lot of data or information through. So like you couldn't send a video feed through acoustic communications. And navigation difficulties, these are one of the primary challenges I've actually been working on since joining the company. So getting back to Greensea, what kind of stuff do they do? Greensea has quite a variety of software and hardware products for the ocean. We have the EOD ROVs. These are explosive ordnance disposal ROVs. So they are used to search for and disarm mines in the water. And so that's mainly like a defense product. We also have a ship hull cleaning ROV and a subscription service, which is really cool, and I'll tell you more about that. We have combat diver propulsion systems. There's a really nice picture of that down on the bottom left. Of course, we have the science ROVs for customers like MBARI and other research institutes. And we have like environmental survey crawlers. This is a nice picture of one right here. So yeah, it encompasses a lot of things. We've done many different custom systems for a variety of interests. And also, these two are the main ones that I've been involved with. So the EOD and the ship hull cleaning. So this is a cool video. I kind of wanted to show you guys, what do our customers see when they are looking at the view screen and controlling one of these robots. This is what we call the workspace. It's the graphical user interface. Operators, this is what they see when they are running a robot around. Hopefully you guys can see it all right. But you have everything they need kind of all in one spot. So you have a sonar display. That's the top one there. You have camera. You have, let's see, do I have a pointer? Yeah, I do. So you have a map area here. Over here you've got heading, so your compass, and even a little attitude indicator, so how you're pitched up or down. Over here we've got a depth indicator. This is an altitude above the bottom, because you may be less interested so much in your depth as you are interested in how close am I to the bottom. So that's what your altitude is, because you don't want to crash into the bottom. And then we have some other controls here, but yeah, that's the main ones. We have sonar controls down in this area here, and so yeah, there's quite a lot going on. So let's talk about my first project at Greensea. This was a little bit trial by fire. So I was actually pulled off of some of the sort of simpler, more introductory kind of tasks that I was initially assigned to, and offered the chance to take on something a bit more challenging by the company's CEO directly, which was a little scary, but I thought, well, why not? And so my task, with this was basically to create some new mapping software. And basically, so over the course of about a year, I created mapping software that tracks and identifies different types of objects with a primary focus on mines, so explosive devices in the water. And so, this was a defense project, and this was part of a larger project to create a semi-autonomous tetherless ROV, which I know sounds a little contradictory to some of the things I was defining earlier, but even though it's tetherless, it's still operated by a human. It's just that it only receives just a couple commands through the acoustic data system that I mentioned before. So you can send it basic commands, like you can tell it to start, you can tell it to stop, or cancel, and you can also send it a mission to complete. But everything else, it does on its own. And also one of the cool things about this project was that if the robot gets into any kind of trouble, if it detects anything wrong, it knows how to rescue itself, bring itself to the surface, and take itself to a predetermined point to get picked up, which is pretty cool. Yeah. And so getting a little bit more to my part, which was the mapping aspect. So we nicknamed this software Target Map. It combines data from a variety of sensors and target recognition systems, basically to predict the object's position, classify it either as this is a mine-like object or not a mine-like object. And within the mine category, it could even recognize different subcategories of different types of mines. And it also would build like a confidence level, like from 0 to 100%, in whether this was a mine or not, its position, and stability over time. And one of the neat things about this was we actually had an AI model that was trained on how to recognize various sonar images of mines. And so basically we had this machine learning model running and looking at sonar images, and if it thought it saw a mine, it would send that information to my application, and my application would add that to the collection of all the data to make a determination on whether or not it was a threat. And during this project, I did quite a lot of travel, which was pretty fun. It was mainly for customer demonstrations, but also to different test sites. We can do a lot of testing actually right here in Lake Champlain, which is really cool, but that only works well in the summer. So when it's winter, we end up sometimes needing to travel to do some testing. The customer demos themselves, they can be kind of stressful. There's some long hours, sometimes 14, 15 hours, everything's going wrong and you have to fix it all last minute. But they're also a lot of fun and they are really rewarding. And so these are some images of me, out in the Florida Keys, out in San Diego, really nice warm places in winter. And our client was very, very happy, with what we showed them, thankfully. And we actually are, we have a new contract with them to do more. So this is really good. So the next project, and this is my current project. This is for a green sea product called Everclean, and this is the ship hull cleaning robot. And what is hull cleaning? Basically you're just removing all the slime and the hard growth, like from the hull, through some kind of mechanical means. Like brushes. It can be water jets and things like that. Our particular robot uses brushes, spinning brushes. And in addition to that, like I said, we offer a subscription cleaning service on a monthly basis to ships while they are in port. So just to talk a little more about why do we need to clean ship hulls. Number one is to deal with invasive species. Dirty ship hulls spread a lot of unwanted critters. They are a significant vector for transporting invasive species, such as, you might be familiar with the zebra mussel. That's one a lot of people have heard of, and is not good for our lakes. So this is a big reason why you want to have a clean ship hull. The other reasons are purely economic. the biofouling can cause a 12 to 29% increase in hull resistance or drag as the ship moves through the water. And that can result in $2.3 million a year in fuel costs extra per ship annually, which is,
Wow.
yeah, we're talking big ships here, but yes, yes. And I don't know the exact ship they did that study on, but it'll be a large ship like a cruise ship. So it's a lot. It's definitely a big deal, and so there's a lot of interest in this. Of course, the other reasons have to do with climate change. The increased fuel emissions, they contribute towards greenhouse gases. This can, heavy fouling can cause over 20% increase in fuel consumption. This equates to millions and millions of tons of CO2 per year. You think about all the shipping in the world. That's a lot. So, and biofouling happens really fast. And this image really shows that. The top panel is, the freely letting it grow. The bottom panel shows kind of a stripe of where our robot came and cleaned that same area. So, basically, our EverClean service, it maintains, the coatings. It doesn't damage the coatings on the ships, and removes all this nasty gunk. And thankfully, our EverClean service is now approved in over 20 different ports, and there are new approvals coming in all the time. We do have to get approval to operate in the ports, due to regulations, security, and also environmental regulations. So how does it work? We come to you. Our technicians, they have a van, which is transported to the port, the robot, and all the equipment inside of it. Once there, they actually operate the vehicle from inside the van. The ROV uses, it goes over the side, it uses its thrusters to fly like a regular ROV up to the side of the ship, and then it actually suctions itself onto the side of the ship with its thrusters, with its vertical thrusters. And then it stays suctioned to the ship and uses the treads to move itself along, the sides and the bottoms of the ship. And then you can see in the front there, there's the brush deck, which actually does all the cleaning. Yeah.
Does that mean then that if there were zebra mussels, for instance,
Mhm.
attached, where would they go? Did they drop down into the bottom of
They
the
just,
ocean?
yep, they just fall down. Yeah.
Where they're just available to keep.
That's a good
keep
point.
producing? So you don't try to vacuum anything up or anything
Yeah,
like
we
that?
don't. Now, that doesn't mean our customer couldn't be making an effort at the same time to collect any, detritus. But yeah, that's actually a really good point, because zebra mussels, I would think, my initial thought would be that they would probably be just killed by this process, but they're pretty tough, so that's a good point, and I'm not super sure. So yeah, we may have to think of something to get all this stuff off and catch them. So, getting back into the navigation side of things, it's pretty hard to navigate on these ship hulls. Like I said, we have no GPS, except at the very beginning when you're still above the water. The vehicle is flipping over, many times. There's metal from the hull, and that's going to be interfering with your compass. And so, we have to rely on inertial sensors to measure how the vehicle is accelerating to kind of tell where it is. And that works okay up to a point, but it starts to drift off over time and accumulate more and more error. So this picture here shows kind of what we would like to be doing, which is sort of this nice back and forth lawnmower style pattern. But because of navigation inaccuracy, we end up missing spots in between those lanes. And so, that's a real challenge. So because of that, we actually can't let the robot do these passes back and forth on its own, we have to have a technician hand flying it, hand driving it, in order to make sure we don't miss spots. So we really need to get the navigation working better so that we can let the technicians rest, you know, and not have to be babysitting the entire time. So how do you improve navigation when you are faced with challenges like this? One way we can do that is using something called SLAM. And SLAM is simultaneous localization and mapping. It is a mouthful. But basically what it is, it's a mapping method that allows robots and other autonomous vehicles to build a map and localize itself, so figure out where it is on that map, all at the same time. And basically, you know, you can see here, there's a couple of images of maps that have been created by robots using SLAM. The famous Roomba vacuum, right, uses SLAM. It uses this technology to understand its surroundings, build a map of your living room, and figure out where it is in your living room. And that's basically what I've been trying to work on doing for this Everclean robot. But the problem is, SLAM is really hard underwater, of course. Everything's harder underwater. And the main reason it's so difficult is that sonar is very, very noisy. We can't use our camera systems either because of all the silt and dirt that gets stirred up in the cleaning. And also, some of the ports, the water is absolutely filthy. You can't see 6 inches ahead of you with a camera in that water. And so, unfortunately, cameras are not a reliable way to do this. Typical SLAM systems on land, like the Roomba or like a self-driving car, they will use, you know, like 3D scanning LiDARs, which is a laser scanner. That's what these images were, these very pretty color images. But those are a lot less noisy. They're also 3-dimensional. And the sonar we are using is only 2-dimensional. So how are we going to do this? It's pretty hard. And basically, once again, we have AI, artificial intelligence, coming to the rescue on this problem. So instead of making the really complicated maps like I showed in the previous slide, instead we're going to use artificial intelligence to kind of see through the noise in the sonar and find recognizable ship hull features. That basically, when the robot comes back around and sees that thing again, it knows, oh, I've seen this thing before, and that's how I know where I am. It's then gonna draw these shapes using, you know, 2D geometry. We can make an assumption essentially that we're on a flat plane, because these big cruise ships kind of have box-like profiles underwater. So there's not a lot of slope and curvature where we are operating. So we're pretty safe assuming 2-dimensional stuff for now. Even though it's not, you know, in the future we'll move into 3D, but one thing at a time. And so far, this approach has been, you know, showing a lot of promise. There's still a lot of challenges to work through. I've been doing a lot of my work on this problem in simulation, but I did recently have a chance to try out this software on a real ship for the first time down in the port of Galveston. And that was just a few weeks ago. And you know, it was a mix of outcomes, right? We had some good things, really encouraging things, and we had some challenges that we clearly still need to work through, such as, you know, being able to know for sure which objects you've seen before. Also, in the AI detector, there's a kind of a bit of jitter, you know, in the image. That a lot of that will get better with improvements to the machine learning model, which, you know, you feed it, as you feed it more and more data, the better it gets at recognizing whatever it is you want it to recognize. So we are continuing to just pump it full of more and more data. A lot of that will get better. So, you know, it's an ongoing effort. The outcome is still to be determined, but we're really hopeful, and I've had a ton of fun, absolute ton of fun, working on this stuff. So with that said, does anybody have questions? Yes?
Can you give us an idea of the physical size of your robot and the dimensions?
Yeah, absolutely. So let's see, I'll back up to the EverClean robot.
Yeah.
So let's see this. So this picture here. So I would say the long side of it is maybe about this long. And then like the brush deck, like when you're facing it straight on, is probably about this wide. So about like this long, this wide. And pretty low profile, like pretty flat.
How fast does it travel?
Good question. I would say probably at maximum maybe 2/3 of a meter per second, maybe.
Oh.
It can be pretty speedy. Yeah, it really travels. It only takes it a couple of minutes to go up and down, you know, say a 100-meter section of hull. It's pretty fast.
How long does it take to do the whole ship?
Good question. So it usually takes a couple of days to get, I would say, maybe half the ship done. We're talking giant cruise ships. So like, picture Harmony of the Seas or like a really large cruise ship. So, from what I understand, the technicians will go. They will be able to do about half the ship over the course of a weekend, and that's like working from like, you know, maybe 7 a.m. to 3 p.m. And then they will come back the next weekend and do the other half. And so they kind of rotate which half they're working on. Yes.
Two questions actually. What did they do before this, and what are the RPMs of the brushes, and does it know if a brush like malfunctions?
Yeah. Okay. So, all right. So what was the first question again?
What were they doing before this?
Okay, so what were they doing before this? Yeah, so before this, hull cleaning was a task that was done by hand. And so you would have human divers going down and scraping this stuff off. Or it just wouldn't get done until the ship was brought into dry dock for other types of maintenance. Or it just wouldn't get done at all. And you know, people wouldn't really care. So yeah, it's always been an intensive process. And then the second part was about the brush deck.
Yeah, like how fast do they spin, and does it let you know when there's a malfunction?
Yeah, so so the brushes on the brush deck, I am actually not 100% sure how fast they spin. I've never worked actually on the brushes themselves, so off the top of my head, I can't tell you like the RPM, but it's pretty fast. They are soft though, so they're gentle. You know, you don't want to damage the coatings on the ship that you're working with. But they, as far as malfunctions, yes. So you know how I showed you that workspace where it showed the sonar and camera and all that? Well, there's some other pages that you can click into that shows all the status of all the different subsystems on the vehicle, including thrusters. So you can check on the health of anything and for any faults that may come up. If you do get a new fault, you will get an alarm that pops up on the screen that will let the operator know, hey, you've got a brush decoupling, it's, you know, whatever, anything that goes wrong, they will be alerted of it. So they can stop the vehicle or they can reset whatever, they can take care of it. Yes?
Hi, have you found any similarities, like both mathematically or otherwise, in the techniques you use to generate your position from SLAM, as you did generating target position from sensor data? Because they're kind of the inverse of each other.
Yeah, so there is a lot of similarities there. But the key difference with the target mapping application is that we didn't use the targets to try to figure out where we were. And the reason for that is that we didn't really need to in that application. Also because in a regular ROV, not a ship hull cleaning one, you are able to periodically come up to the surface and grab a GPS fix. So you don't have to worry about it so much. But there's definitely been a lot of talk at the company over time about could we kind of combine these things somehow so that the defense robots can track, the objects they see in the water and actually use that to help with where they think their position is. So there's definitely some talk about using that mapping stuff as an input to something like SLAM. But yeah, we haven't done that yet, but they're definitely related.
Right. Can I follow up?
Yeah.
So, right, so that makes sense. So I'm just, I'm wondering if you personally in your work have found that any of the mathematical operations that you utilize in one sense where you have known position and you're placing a sense target onto a known map are similar, inverse, or just completely different than the ones you use when you're standing forward
Yeah.
to generate a known position from, like, the opposite?
Right, right. So,
Or if they're completely different approaches.
they are I will say they are completely different. So, and I can't get too in depth on it just because of the company confidentiality and
Yeah,
that
that makes
whole
sense.
thing. But although it is fun, it's fun math. I will say the SLAM math is much trickier than the target mapping stuff. It's fairly simple, to compared to SLAM. But I can't really get into too much depth on it, unfortunately. Yeah.
Can you tell us a little bit about your company, are they Vermont, because they're Vermonters, or they like to be in size?
Yeah, so why is the company in Vermont? That is mainly because of our CEO. He is a Vermonter. He lives very close by the office. He has kids that he wanted to raise here in Vermont. And basically, as long as he's the CEO, we're going to have a Vermont office just because he loves it here and doesn't want to move. We also have a really great resource in Lake Champlain as a place to test. It works out pretty well. And then when we can't test in the lake, we've got our other offices that are closer to the ocean.
So you have satellite offices?
We do, yes. One in Plymouth, Massachusetts, and one in San Diego, California.
It's a fairly big company.
I would say, I wouldn't call it huge, but maybe a total between the three offices of about 75 people. So kind of, moderate, but not huge.
So,
Yes.
when you're testing in Lake Champlain, where does the boat dock and, where do you start from?
Yeah, so the question is, when we're testing in Lake Champlain, where does the boat dock from and where does it start from? And that's a great question. So, I don't know if you guys have ever been down to the dock where the ferry is, like the King Street dock, or the boathouse dock. Both of those areas are places that we will launch from. And usually what we will do is we will charter a boat to take us out. I think the one we've been using the most, or that I've used the most, is the Burlington, Harbor Tow. They have a little, it's not a very large boat. I should have included a picture of it, but it's maybe a 25 or 30 foot long boat with just an open deck. It's very easy to pick the vehicle up and put it over the side. And it's a working boat, so they don't mind us bringing our equipment on there and stuff like that. Occasionally we've had employees have allowed us to use their personal boats on occasion, but most of the time we charter one. Way in the back.
What first team were you on?
Oh, okay. So I was on first team number 716, called the Housatechs, and they were. This was in the Housatonic Valley Regional High School in northwestern Connecticut.
I love those guys.
Yeah, thank you.
You were the tie-dye?
Yes, we had the tie-dye shirts with the question marks. Yes.
And Mentor's still there?
I believe so. I think though that the chief engineering mentor, his name's Andy, he is retiring from doing that, and I think they could be having some trouble finding someone to take over, and so the program, I really hope it doesn't end. but there is a possibility, I think, because he's done it for like 20 years, you know, it's time for him to,
He was a dairy farm, right?
no, he's an engineer.
Oh, was there a dairy farm? I'm sorry.
No, it's okay. I don't know, do you know the Freunds, like the Freund farm? Because their kids were involved in the team. Maybe that's that connection there.
Okay.
But no, Andy Brockway, he's an engineer who works at Becton Dickinson, which is a local manufacturing plant near my high school. And he was our engineering mentor who came and helped us. We also had teachers and other school staff involved in mentoring us too. Yes.
I'm curious to know, based on like your second or third slide, it looked like you're using open source circuitry. How are you using open source? Like, are you using it in your programming, in your applications, for communications?
Yes.
What type of communications protocols are you using?
Yeah.
Things like that.
So the question is, do we use open source libraries, software, etc., and what communication protocols are we using? And for communication, we are using LCM, which I'm trying to remember what that stands for. It's something communication and marshalling. So it's LCM is the communications protocol. It's via Ethernet. And then as for open source, yes, we use a lot of it. So all of our software runs on Linux. Either Ubuntu 18.04 is our older systems, 22.04 is our newer systems, and so of course the operating system is open source, and then a lot of our libraries are open source as well. So for example, in this SLAM project that I'm working on, I'm using a library called Point Cloud Library, and that is open and free for anyone to use. So yes, it definitely plays a role. We do have to make sure that the licensing on it is something that is available for commercial use. So you have to kind of be careful of that, but the answer is yes.
So are you importing these APIs into like an open source language like Python? Or
Yeah, so
something else?
we actually primarily use C++. So I am primarily a C++ programmer, and so is the vast majority of our code. So Python, though, we do use for a few things, mainly to quickly prototype, test code, quickly iterate things, or to do some data processing. That's code that's never really going to be given to the customer. Slowly that is changing, though. Slowly we are starting to develop some better ways of handling things to do with Python so that it's in a state that's deployable to the customer. But for now, we are mainly a C++ company. Yes?
I wanted to ask you more about mines that might be underwater.
Yeah.
How deep would there still be a danger for a mine exploding? Like, would that be just in harbors that you'd be concerned about?
Yeah.
Or would you also be concerned about something exploding in deep ocean water?
Yeah, so from what I know, and I'm not necessarily a munitions expert, but from what I understand, mines are mainly a shallow water concern. So, I would say, I think, so the ROV that we did for the EOD stuff, I think is rated to maybe like 400 meters depth, which is pretty deep, but I don't expect it'll really ever need to go that deep. So I'm going to say, it's probably primarily a concern in depths that can't be much more than a few hundred feet of water. But I'm not, like I said, not a mine expert. But yeah, I think it's shallow water. Also, mines can be put in the surf zone, and they can be put on the beach too. So one of the pictures I had, maybe I can go back to it, is of it's of a tidal crawler. So you see this one here that's towing the sled? This is a sled. It's towing to try to detect munitions that could be buried in the sand. So you can actually use these EOD crawlers, and this crawler can drive in and out of the water to find things that are really in that surf zone and in the beach zone as well.
And then would it be detonated if it was, I mean,
Yes.
is that's the point of it, I'm sure. but
Yes, so
Not
absolutely.
by you, by somebody else that was
Or
trying
is
to
it
clear an
Actually
area?
detonated as opposed to disarmed?
It's
Is it not the same
detonated.
thing?
Yeah, so, so the robot, so the project I did with the mapping, that robot, some of the behaviors that we programmed it to do involved how to approach the mine, attach a charge to the mine, back away from the mine, and then the charge goes off to disarm it after the robot has backed away. Yeah. Yes, and
For, let's say a large harbor, are you talking about like one of your pieces of equipment, or would it take dozens of them to either find mines and to control, to prevent mines? Are we talking about one machine to do a big harbor, or it takes lots of machines to do a big harbor?
I would imagine it wouldn't take too many. So when we demoed that project, I would say, well, we only had one vehicle, but we were covering pretty large areas just with one vehicle. The vehicle's pretty speedy. So, the crawler, like I said, is maybe like 2/3 of a meter per second. But the ROV can move at like 3 or 4 meters per second in the water. It's pretty fast. So it can cover quite a bit of ground. I think the main idea is to use them singularly, maybe more than one if it's a particularly large area, but yeah. Yes?
You mentioned earlier something about harnessing the energy of the ocean waves
Yes.
and currents. Is your company looking into producing energy with that?
That's a good question. So the question is Green Sea doing any projects with wave energy? And as far as I know, the answer currently is no. I think it's possible that maybe in the past we've done some custom software for other companies that were doing that. But we are not currently making products for that right now. But it would certainly be within our mission statement and the kinds of stuff that we like to do. So maybe in the future. Yes?
Sorry,
It's
one
okay.
last question about, your ROV,
Mm-hmm.
or the, is that the, wait, or the, what's the one on the beach?
Oh, so we have the crawler here.
Yeah, the crawler, and that can go into the water, right?
Yes.
And does it, also, like as it's going in, determine what it's going over, because, like it might
Yeah.
disrupt some of the sea life when it's going into.
Yep. So the question is about how does the crawler avoid objects it doesn't want to encounter? And the answer to that question is we actually have obstacle avoidance software. And basically the way that works, so we have sonar, right? We have some software that looks for bright reflections in the sonar that are persistent over time. And actually in my target map application can take some of this as well as an input. And basically when it has a lot of confidence that there's definitely a rock there, or there's definitely something you don't want to get into there, we have software that kind of calculates how to drive a path around that object and then continue on to where you want it to go. Also, the operator can hand draw in the workspace keep out zones, so to speak. So if you know ahead of time where there's an area you don't want the robot to go, you can draw an outline around that area and it will not go in that area. So, yep. Yes?
I was just thinking about how you said that the flipping over and inverting of the ship cleaning one is a particular challenge.
Yes.
And I was wondering if you could just elaborate a little on a high level on the specifics, like
Sure.
how you guys deal with this, and maybe if it's not actually so different from the Roomba, but in 3 dimensions after all.
Yeah, so the way we deal with it for now is, so when you look at a cross-section of the ship hull, it's pretty square, at least the ships we've been working on so far. So that's, the cruise lines and stuff like that. And that's kind of fortunate because that means that when we are either on the sides or on the bottom, we can kind of make an assumption, right, that we're just on a flat plane. And when we, basically the way we do it, so when you're in normal operation, not on a ship hull, just flying along regularly, on the, on the workspace you have latitude and longitude and your map flat, and then, your depth kind of goes straight into the computer screen is how you would picture that third dimension. So what we do is when we attach to, say, the side of the ship, we trick the navigation system to think that up is like north, and sideways is like east-west, and down is like into the ship hull. So we kind of trick our own navigation system to think that it's flying straight and level, when it actually isn't.
So a change of coordinates into Roomba coordinates.
Yeah, so it is. It's like changing it's like changing your reference frame to kind of pretend that you're normal, even though you're not. So I hope that helps. Anything else?
Is there any more?
Mom?
Yeah, so I'm her mom, so I know a little bit about what the answer is going to be, but I think it's important that you talk a little bit about being a woman in this field and what you've encountered in school, just, the differences maybe.
Yeah, sure. So I will say that I feel like I'm pretty lucky to have had really, really good experiences for the most part as a woman in this field. Even when I worked at Bombardier, I was the only woman in that building, and it was a bunch of blue collar guys. It ended up actually being a really positive experience. Those guys are a little rough around the edges, but at the end of the day, they did respect me. They did have to get to know me a little bit first, which isn't, the greatest, but they did respect me at the end of the day. And, definitely could have been very different. And I think that nowadays, it really depends a lot on the particular company that you end up working for and what that company culture is like. I hear all kinds of stories from women working in the field. And some of them are having a great time, like I am, and then some of them are really not having a great time and are struggling. And so, I think it really comes down to having a really open and company culture that also provides you with a means for accountability when things don't go wrong, that people can be held accountable, I guess I should say. And yeah, I think some of the hardest things I've ever dealt with, I guess I'll say there's two things. One was in school. I think in school I struggled a bit socially due to the fact that there just weren't many women around to make friends with. And, a lot of times the guys had other motives, right, to want to get to know you, especially when the school was 70% male and only 30% female. That was Florida Tech. SUNY Plattsburgh had more women, but I was also older, and that had its own set of social difficulties. But yeah, I think it can be socially isolating at times when you're in school. And sometimes the boys don't want to treat you very well. They don't want to listen to you. Or you have to, really prove yourself in a way that maybe some other people wouldn't necessarily have to do. And, again, I was very fortunate with my professors that my professors were all very, very supportive, wonderful mentors. But I did not have one single professor who was a woman.
Wow.
Not one in either school, other than for elective classes that were non-engineering. And so I think that's kind of a concern. I think that representation matters. Seeing women, and I think this goes for other minority groups too, right? Seeing people who look like you do the things that you want to do really makes a big difference. And it makes you feel like, you know, yeah, I can do that too, it's no big deal. But not having a single female professor, I think is, I don't know, I find it kind of sad. And I really hope that that changes, you know, in the future. I think another challenge that women face in this field, and I think this has to do a bit with the lack of professors, is there's a problem with the retention of women. Even if they do graduate, they get interested and they go to a college degree program and they graduate, a lot of women won't end up staying in the field. And either they'll change careers, maybe it's because they were mistreated, or maybe it's because they had a lot of obligations with children, or whatever it is, but there is a problem with retaining women. So, you know, there's a ways to go, but I definitely think, you know, I've had a great experience overall. So, yeah, if that answers your question. Yeah.
How
Did
many
you learn
women
anything,
in?
Mom?
How many women or percentage of women are there in Green Sea?
Yeah, so I'm not the only woman engineer at Green Sea, thankfully. So I am one of 4 women, and that's a pretty small percentage though, to be honest. You know, I'm thinking our software team probably has maybe 25 people on it, and only 4 of them are women. So it's still a pretty low percentage. Yeah, but I'm not alone.
What was your degree in? What did you actually?
Yeah, so I actually have 2 bachelor's degrees. One is in physics, and the other is in robotics. And because I was a transfer student, it's a little confusing. My first major at my first college was ocean engineering. So that had some of the more ocean-specific education in it. And then when I went back to school, it was just robotics and physics. Yeah.
So you got those 2 separate degrees by combining from the 2 colleges?
Yeah, so I had so many transfer credits from my first college that to declare a second major in physics was not going to take me having to take too many more classes, because there's just a lot of overlap between physics and engineering. So I just decided to add it and do a few extra classes and get the dual degree.
I wish your company would send you out to high schools to talk to those
I would love to.
budding engineer girls.
Yeah.
Pay
Yeah.
you to go like once a month to a high school, different high schools around.
I would love to do that, honestly.
Well, you do a great job.
Oh, thank you. Thank you. Yeah, you know, if any of you guys know of any places that could use a speaker on something like this, definitely let me know.
Awesome.